Imagine a Docker image that only contains a single binary of your app. Then imagine if it can run on any host without having to rebuild a new architectural image. Oh yeah, and it's also smaller, way smaller, by sometimes order of magnitudes smaller image. It starts faster, it defaults to higher security guarantees, the list goes on and on. But imagine that future for a second. So in this talk, we're going to cover what is cloud-native WebAssembly and how is it different than the WebAssembly you maybe heard about years ago, how Docker is innovating in this space, and how you can get started. Let's do it.
Hi, I'm Nigel Poulton. I'm a Docker captain like Bret here. I've been working with Docker and containers and Kubernetes for like too long, but now I am in the weird and wonderful and crazy and scary world of WebAssembly, or sometimes as we call it, Wasm.
Hi, my name's Bret. All right, we're talking about Wasm. What is the origin of WebAssembly?
Although it had nothing specific in its like initial specification and implementation that specified it had to be for the web, despite the fact that it's in the name, right? Web and assembly. It's neither web nor assembly, actually.
Perfect.
But obviously the first major use cases, were in the web. And I think the idea, and I'm careful how I say this, but I think the idea was that JavaScript, let's just say, had its challenges, still has its challenges, and that there was a way to kind of do applications like that in a better way. So originally, when it was first implemented in a bunch of browsers, people were thinking like, is this going to be the JavaScript killer? Obviously, that never happened. So WebAssembly itself is its own bytecode, which I get, look, for all intents and purposes, is almost like its own machine code. It's like an intermediary layer, actually, but it cuts out some of the steps when you're compiling JavaScript apps and things like that in a live environment. Going from your code to an executing application is much quicker with WebAssembly, which is why WebAssembly tends to be the go-to solution if you're like creating high-performance web apps. Was it 2017 or something like that we first started hearing about WebAssembly, and it was your likes of Mozilla and Google and Apple and people like that were all behind it, which are web giants. And I guess then it's no surprise that its first implementations were in the web. So WebAssembly did a really good job on the web of making applications faster, while at the same time being secure and portable, because everything on the web has to be secure and portable. Yeah, and a bunch of people saw that and they were like, oh, I tell you what, I'd like to build some cloud platforms that have got some of that goodness in it. That's the origin story according to me.
Yeah, so if we're talking about it's running on the server, are these binaries that we're building? It feels, is there something else involved with, if I decide to take a Node.js app or a Python app, because I hear that there's all these languages now that you can make into Wasm binaries. Before Docker, like what would normally be on a server before, so I could run one of these new Wasm things on a server?
So to run a Wasm app on a server, you need a Wasm runtime. So you take your code in whatever your favorite language is, right? And don't get me wrong, not every language can do this yet. The list is growing. It's not as big as we would like it to be. It never is, right? But more languages are coming on board. And when I say on board, it's the ability to take your source code and instead of compiling it for Linux on whatever, ARM64 or Windows on x64, whatever, you can now compile it to a Wasm binary because it's its own bytecode, really. Okay. But in order to run that, you need a Wasm runtime. And there's a bunch of them out there. Probably the most famous one, it's the Bytecode Alliance reference implementation, actually, but Wasm time. You can run it on Windows, Linux, Mac OS, probably others as well. And as long as you've got that, you can take that Wasm binary that you've compiled from your favorite programming language, just execute it like it's a normal application. And you get near native speeds from it as well. In fact, I have heard some instances, and we can maybe come back to it later under performance, where you can potentially get better than native speeds. And I remember the first time I heard that, I was like, better than native? What? You're pulling my leg, right? How is that possible? But yeah, basically the story is you take your code, potentially at the moment, a typical microservices application written in whatever languages. If that languages compiles down to Wasm, great, do that. And anyway, you've got a Wasm runtime, bingo, you can run it.
The nice thing is, those of us in container land, we know about runtimes because when we're running a container, we're used to having something on the server. What did Docker do that sort of helped out the Wasm community?
Okay, there was a project in the community called Run WASI. I believe it was created by the guys at Deus Labs, acquired by Microsoft recently. By the way, I like a lot of what they're doing in the open source space. But this Run WASI it's a containerd shim. And what it lets you do is, say, you can even have a Kubernetes environment, right, that's scheduling workloads. And it schedules workloads to a node. There's a kubelet on the node, and the kubelet will say to its container runtime, which quite often is containerd, hey, run this piece of work for me. And we know that containerd usually has a shim, and then it uses a low-level runtime called runc, quite often, out of the box, that's your default, to actually execute the workload. However, from like Kubernetes perspective and even Docker's perspective, almost everything below containerd is opaque. Like you can swap out runc for a different runtime. And because it's opaque below containerd, there isn't really anything stopping containerd executing WebAssembly workloads. And in the architecture, you've got Docker Engine scheduling work to containerd saying, hey, start up this particular work task for me. If it happens to be a WebAssembly work task, then it calls the containerd, the Run WASI shim, which sits in between containerd, and then in this example, it will be Wasm edge at the bottom, which is just a WebAssembly runtime. So look, Run WASI sits between containerd and abstracts like the low-level sort of Wasm runtime machinery from containerd. So containerd really doesn't know that it's running a Wasm workload versus a container workload. It's just saying, start a piece of work for me, stop a piece of work for me, delete a piece of work for me. The Run WASI shim lets us plug in a Wasm runtime into those kind of environments. Now, what Docker did was they took that Run WASI shim, took a fork of it, and they made it so that a particular WebAssembly runtime called Wasm Edge would work with containerd. Now, look, since then, this Run WASI project has been voted in as an official containerd shim. So it's now been upstreamed into the official containerd. Really good stuff is happening there at the moment. And that's very much thanks to the Microsoft Deus Labs people, Second State, Docker, people like that, not only investing like developer time in it, but including it in their tools and things like that so that it's getting more use, it's getting out there. And I dare say, look, containerd with the Run WASI shim is looking very much like the most likely route to getting WebAssembly workloads on Kubernetes going forward as well.
Okay, so given all that, when should we be looking at WebAssembly for cloud native?
So this is where we get into like the realms of it's super early days with this kind of stuff. And you'll remember, and a bunch of people watching this that were in early with containers, is that there was... You're always battling with that appetite to run as much as you can on it and push the boundaries when maybe the tooling and the technology isn't quite there yet. And we did a bunch of that with containers and with Kubernetes, but they've matured a lot more. I feel like we're very early days with this. So right now, WebAssembly workloads have outrageous cold start times. So that makes them like super good for event-driven, like function as a service type things. But also because the binaries that they produce are so small and so efficient, then they're also a great choice for anything that's like out on the edge where maybe you're resource constrained. I would say that at the moment, right, yes, you can get away with running other workloads on WebAssembly, but I feel like you're going to be hacking a bunch of stuff together in order to do that. And it just feels like, for the meantime, outside of that event-driven function as a service type model, or maybe out on the edge, containers is really still the go-to model for everything else, because not only are the core technologies baked and understood, but also the developer ecosystem, all the tooling, the support from third parties and things like that is there.
That brings up a good point. What's in the image that I make? So if I take your Rust app you talked about, normally with Rust people, we would build a binary, right? A Golang would have a binary. And we're used to in those worlds of having a very small image because we maybe don't even need anything other than those executable binaries. They're built for Linux or for Windows or whatever. A lot of us are still in Node.js or Python or Ruby or whatever, and we're adding often many thousands, if not tens of thousands of files with all our dependencies. I will look at some of these apps like Ruby apps and Node.js apps, especially with the default built-in base images, and there'll be 200,000 files in that image. So how does Wasm improve on that?
Let me compare it to just a traditional app in a container, right? So we would start with a Docker file and you would have a base image. And that base image has got a bunch of, let's just call it a minimal operating system. Most of us probably know this, right? It's got a bunch of file system structures and things like that. And then you copy in your code and you pull in a bunch of dependencies and things like that. You end up with kind of this layered model with all this stuff in there. This is very different to that. There is no real concept of saying we need to package a minimal operating system with it. Now, look, this may change, but right now, when we're like writing HTTP handlers and things like that, basically you're just taking not a lot of lines of code, and I'll just use Rust as an example because we're going to see it later, and you just compile that down to a release binary. So I guess a lot of languages will have a way to compile like a release version of a binary that's basically got all of the debugging tools and things stripped out, and you take that binary as a WebAssembly binary and you just run that. The WebAssembly runtime provides everything that's necessary in order to execute that. So Docker have done a really good job recently of folding WebAssembly into our existing tool sets and our existing platforms and things like that. So instead of having to like get rid of all of the tools that we've used in the past and learn everything from the ground up new, not only WebAssembly here, but a bunch of new tools and new platforms and things like that, Docker are doing a really good job of saying, look, we've already got great tool chains here. We've got a great registry and all of that. And adapting those tools to work with WebAssembly. Now, if you do that, current way at the moment is to take your WebAssembly module or your WebAssembly app and package it as an OCI container. Of course, Docker does that. We'll see a little bit later in the demo. But to do that, it starts from a scratch base image because you need to do that in a Docker file just to build it. But once it's wrapped in an OCI image, then you can host it on Docker Hub or somewhere else where you can then use Docker run to run it, all of that kind of jazz.
Yeah, you and I were at KubeCon, and Kelsey Hightower from Google met with the CEO of Docker, SJ, and they had a fireside chat, they called it. And I loved it because it felt like it was a conversation about Wasm for mere mortals. And of course, Kelsey does what Kelsey does. He always breaks down the myths and the hype. And one of the things he really pointed out that we've made all these deployment pipelines with containers now. We've all spent the last close to 10 years now building systems to deploy images using all the standard OCI specs that we all now know and love. And that by Docker taking this route, having Containerd bring this in as a shim, it basically allows us to use everything we already have today for this new type of binary. Because they could have just said, let's just ship a runtime in your image with your app. That's essentially, to me, as a Node.js or a Ruby developer or a PHP person, that's what we're doing. We're all just shipping the runtime with our source code. I like it how it flips it on its head and says, we're going to handle the runtime, and you just ship your bytecode that sort of, I think of it as like a middleware, like it's this middle layer that is efficient. Like you said, it's super small because it's not including hundreds of thousands of files. It doesn't have to have all these image problems that we've dealt with, especially like we talked a lot about DockerCon, where we talked about images having all these vulnerabilities in them because of all the unnecessary files like package managers and curl and shells and all these other things that maybe you don't need in the container, which spawned this whole other industry of how to reduce image size. Well, if there's only one Wasm binary in my image, like it's not going to get any smaller than that. So I look at this as a win for us operations and DevOps people as well, because granted, it's going to be up to the developer probably on whether they decide to do Wasm. But if they're going to ship it to me, I'm going to be able to run it. So let's get to the next part, because I feel like for people that are now grokking a little bit of what WebAssembly is for container native, they're probably asking, how do we do it? What's my first steps? If I'm interested as a developer and I'm already got Docker desktop, what are my next steps?
Yeah, so I suppose you need to make sure that your languages that you write your apps in support compiling down to WebAssembly, because really WebAssembly, at least the way that we expect to use it, isn't as like a new programming language. Yes, you can do it like that. But generally speaking, we're going to take things like Rust and Go and Python and stuff like that and say, we're going to keep writing in those languages, and it compiles down to WebAssembly. So I think that's your first step. Does your language support compiling to WebAssembly? After that, you need to decide, look, if you've already invested in Docker and Kubernetes and things like that, it is probably a good way to go because you've made an investment in a platform and things like that. It's pretty early days still at the moment. So a lot of this stuff is going to be in beta or tech preview for a bunch of this kind of stuff, maybe for a little while.
And so Docker announced Docker Desktop supporting Wasm at KubeCon. What does that do for us in Docker Desktop?
As soon as you've got a WebAssembly module or a WebAssembly binary, you can write a Docker file that will wrap that in a container image or an OCI image. You can then use Docker push to push it to Docker Hub. You can use Docker run to run it. And basically, it's almost as if it's not even a WebAssembly app, other than the fact that you get a bunch of the benefits of WebAssembly because you're just using the tools that you use every day.
And that's specifically a Docker Desktop thing right now. Like, I'm guessing that Containerd eventually will have an ability for us to run this in Kubernetes.
That's right. And I think Ralph's probably going to talk about it in his Azure session a little bit later, but just to tee Ralph up if he does. So Azure Kubernetes Service, AKS, already has in preview the ability to have Wasm node pools in an AKS cluster.
Okay.
And they use that exact same run WASI containerd shim. And you just define a runtime class on Kubernetes for those node pools. And anytime you schedule a Wasm workload to Kubernetes, it will schedule it to those node pools, and they use Containerd to do that high-level scheduling. Containerd has the run WASI shim in there that then uses Wasm time or others in the future, that kind of low-level WebAssembly runtime to actually execute the work task. So it's already, I'm not going to say it's here for Kubernetes because as we speak, that's in tech preview on AKS. But believe me, this stuff, for me at least, it feels like it's coming fast.
All right, given all that, will Wasm take over the world?
I feel like I should do an evil laugh for that. Look, I think in as much as VMs took over the world in their own way, in their peak, and that containers have taken over the world and potentially haven't even reached their own peak yet, then I don't see any reason why WebAssembly can't and probably won't take over the world the same way that those two have. Like for now, like we said before, it's a bit niche in that it's got some use cases. And outside of that right now, you're just putting yourself into a world of hurt if you're trying to make it do everything else. But I don't know, I feel as the core technologies evolve and then as the ecosystem grows around it, just because like containers, it's smaller, faster, more secure and more portable than the previous generation technology, I don't see why it won't become the dominant model like VMs did and containers are at the moment. Now, look, is it going to take over the world and replace everything else? Of course not. Nothing ever does. Not even containers. Like even in the kind of height that they're in at the moment, we've still got VMs.
So you and I were actually having a conversation before we recorded this, and we were talking with the Docker team. And one of the questions I had that they had to answer for me was, is this different than building a Wasm app for the browser? And the answer I got back, thank you, Michael and team. The answer was like, if you're not running on the server, you don't need this separate runtime, because if you're running in a browser, the browser's the runtime. So if you're a web developer today, this doesn't really change what you're doing for making web browser-based WebAssembly apps, because Docker still could be a great tool for that, like all web development, and you're still going to have your tooling that builds it into the binary that then hosts it on the web server. But what we're talking about here is the other half of that, the things that aren't in the browser, which will need a runtime and some of this tooling in the middle. And why not take advantage of the existing pipelines and all of the container and image stuff that we already have with the OCI spec? All right, so the way to get started is you first need to have Docker Desktop 4.15 or newer, then go into settings, and you're going to enable the Wasm beta in there. Secondly, if you want to get some of the documentation on it, you have a couple of choices. One is Nigel's post that he mentioned before the demo. That's right here. And that is over at nigelpoulton.com. And then secondly, you can go to Docker's website. And if it's still here when you watch this video, if you hover over their logo and click the Wasm under their logo, it'll take you to it's a shortcut to the desktop/Wasm page over on the Doc site. And then you can go to Docker forums, which now have a dedicated section in the Docker forums. That's forums.docker.com for questions about WebAssembly in Docker. And they have a whole new topic there.
I think the idea of this demo is just to give us a 40,000 view of what the steps are, the process, some of the tools. That's it really. And look, anytime you learn a new technology or a new programming language or whatever, we've always got to do a hello world, right? It's a rite of passage.
Yeah.
So from the perspective of a demo, I've got 2 prerequisites that if you want to follow along, you're going to need yourself. You will need the latest version of Docker Desktop. You will also need the Rust programming language installed. And with those 2, the only other step that you would need is to add the Wasm32 WASI target to Rust, which is basically just enabling Rust to take the source code that we're going to write and compile that down as a WebAssembly binary. So look, I'm rubbish at typing, so I'm going to copy and paste commands here. So first command is cargo new hello Docker. That's just going to scaffold up a simple Rust app for us. And within that, it creates a bunch of files and a folder structure and stuff like that. But the only one that we're interested in is the main.rs file here, which, as we can see, is a super complex hello world app. But I'm going to be brave here and go all cutting edge, and I'm going to change it from hello world to hello community all hands and save that. So look, it's
Star Trek nerds, so yeah.
It's got to be done. So actually, when we run the app, I'm expecting the same from you later on, Bret. But look, it's going to print some text to the terminal, right? Very advanced. Once we've got that source code written now, how easy was that? All right, so from within the directory of the application, if we do a cargo build, the -- target wasm32 WASI just says to Rust, instead of compiling this down for Intel on Mac OS, which is what I'm currently on at the moment, don't do that, but create this instead, or compile this as a Wasm32 binary. And then -- release just says, don't include debugging tools and stuff like that, make it super efficient. Bingo, and look at that, it's done. So now that we've got the Wasm binary, I guess we could run that right now just using Wasm Time or Wasm Edge or something on my local machine. But I really want to package it in a container image so that if we wanted to, we can push it to Docker Hub and then use Docker Run to run it later, which is actually what we're going to do. In order to do that, we need a Docker file, which I have got in the local directory here. And if I just show you the contents of that Docker file, super simple, right?
Doesn't get much easier than that. It's from scratch too, right?
Exactly, yeah. So the scratch image here as a base image is really just so that we can use Docker build to actually build it. That base image or anything doesn't get used for anything. It's just, it ends up being an artifact of the build process here. All we're interested in is the middle line. This is going to copy in WebAssembly binary on the end here and then set the entry point to that. So the command to run or the application to run, when we come to run it, when it's all unpacked out of the image and comes to run, it will run our WebAssembly binary. To do that, I am going to copy and paste a docker buildx command, which is basically saying build, set the platform for the image as WASI Wasm, give the image a name, and build from the Docker file in our local directory. Fingers crossed and offerings to the demo gods that this works. Okay, fabulous.
So the only thing different there was you just had to add the platform, the -- platform, which technically isn't a new one, right? We've had that -- platform for years now for you to specify ARM. If you're on Intel and you want to build for an ARM machine, you can specify the platform you want to build for. And that's a feature of BuildKit and the buildx command. So we're just seeing Docker extend this out to yet another type of runtime or another target, a build target.
Absolutely, yeah. Right now, I think all it's potentially used for is if the image is then pushed to Docker Hub. So somewhere in here we go, we'll see that the OS is set to WASI and the architecture of the image is set to Wasm. And that kind of stuff can potentially be leveraged heavily by Docker going forward. Okay,
Ooh, I have a good question for you real quick. What is the difference between WASI and Wasm?
Okay, WASI is the WebAssembly Systems interface. It's an interface for allowing WebAssembly apps to be able to access more like server-side resources. Because I think we've probably talked about this before, that look, WebAssembly apps in a web browser need access to totally different things than WebAssembly apps that are running in cloud servers, like access to the network and access to the local file system and things like that. That kind of stuff is still being baked, and WASI is the API or the way that WebAssembly applications will access host resources.
Yeah, so that means WebAssembly in the browser, like years before, that it didn't really need WASI because it's just a browser app. Usually those things aren't doing all this system low-level stuff. But now that we're doing cloud apps on a server, we actually need the app to do things like talk to the file system, talk to the network or whatever. So you're saying that means we're always using WASI when we're running these things, Or we're trying to use the WASI standard as it becomes a standard or something. Yeah.
Yes. Right now, if you want to do networking and stuff, and especially like moderately advanced networking with Wasm, then you pretty much have to go with something proprietary and hack something together. And companies are doing that, don't get me wrong. But I think the idea or the end goal is like a lot of this stuff will just be exposed through WASI. Okay, this command that I've put on the screen now has wrapped, unfortunately, over the first line. But look, it's just a Docker run. We're going to get rid of the container at the end with the RM. We're giving it a name. Then the runtime, we're saying here, use Wasm Edge. Okay, so it's using containerd. In fact, let me just highlight this here. So we're saying for the runtime, we're going to go containerd, but behind containerd, we want containerd to use Wasm Edge, which is one of many low level. And when I say low level, I'm talking here, we've got containerd as a high level runtime, and then something like runc as a low level runtime. Wasm Edge or Wasm time and things like that are very much in the space of runc, where they sit below containerd. But the one that works at the moment with Docker Desktop is the Wasm Edge runtime. We've got the platform flag again here, Bret. And then it's basically just that local image, which I did change to be this. This is us using our typical Docker tools to run a WebAssembly app. Just honestly, Bret, a really quick recap here. We've built a Hello Car. You're better at me than that. So we've built a Hello Car app in WebAssembly, in Rust. We've compiled it to WebAssembly. We've packaged that inside of a Docker container or an OCI container, and we're now about to run that app. And if this works, please demo gods, we will get something fabulous. Hello.
So in the background, you told the Docker command line this command. Then it passed information to the Docker engine. That's all normal. That's what we normally do. That's running in a Linux VM on your Mac. Then that tells containerd to start an application image, and it says, hey, but this time don't start runc, start Wasm Edge, and you're going to instead of a Linux, you said you're on Intel, so it would be a Linux /AMD 64 image, which would be the default that you would normally run. It's saying instead containerd Wasm Edge runtime, you're going to run a WASI Wasm platform, which is actually architecture agnostic, which I think is fascinating. Like you could run that same image on Windows with a Windows Wasm Edge in theory, and 100%. Then the app is just running like normal.
Yeah, absolutely, 100%. And if anybody's head's like mine is going with all of that, totally normal, because there is a lot going on behind the scenes here, especially if you're new to it. But don't let that put you off, because there's a whole new conversation, Bret, that this is running inside of the Wasm Edge runtime, which is like a sandbox environment with a stack-based virtual machine executing the code. But it's also dressed up in kernel namespaces and C groups and things like that, but not quite a full container, but a bunch of container constructs there as well. So in some respects, we're getting like double security here, 2 for the price of 1 almost. So lots of stuff going on. But at the end of the day, our existing tools and tool sets that we're familiar with, that we know, usually we love, and we're rocking with WebAssembly with them.
Yeah, so we've gained a smaller image with a single file in it without needing a whole bunch of additional tooling or dependencies. Of course, with Rust, that's normally what Rust people are used to, but maybe if you're using something like Node.js or another Python or another language that supports Wasm, you simplified that workflow. And then you're talking about this additional, this is more of a Wasm thing specifically, right? That's additional security layer of Wasm already being sandboxed because it came from the world of WebAssembly, where everything in a browser is sandboxed, so we're used to that model in browser world. And now you're seeing it as a regular image. It only has a slightly different metadata file where it just slightly says the OS and architecture are WASI and Wasm, and not a Linux /ARM 64 or AMD 64 like we're used to. And other than that, not a lot has changed about this. I'm still using the same tooling. I'm still running it the same way with Docker. Presumably when we push this to a Kubernetes cluster or a Docker engine server, like it's just running the same way as before. We might not even be able to tell from like an operator perspective. We're not really maybe aware of what's really going on here that's different unless we really dig into let's assume it's running on a Linux system. I guess I would see the Wasm Edge binaries actually running on the host OS, right? So instead of runc, it would be this other one. So we're just really trading one little runtime for another little runtime. Not a huge lift. So I like it. Let's do it.
Yeah. Do you know what? One last thing, and it hasn't wrapped on the screen. It's perfect size. We can see that it's about 500K. Now, look, I get it that it's just a Hello World app, but I have compared this to a similar one that I've got in a Docker Hub repo that was built with a small container image. And that one was, if I remember right, it was about 4.9 meg. So this one is like half a meg. So for the equivalent, we are still significantly smaller here.
Yeah, this is floppy size, man. We could put this on a 3.5-inch floppy.
Who even remembers what they are? Bet you a bunch of people on the call don't even know. What are you talking about? But absolutely, yeah.
Well, thank you so much, Nigel, for hanging out with me. And we can find you on the web down there at Nigel Poulton on Twitter, nigelpoulton.com. You can find me, bretfisher.com, at Bret Fisher. We're basically all over the internet. Thanks, Nigel.
No, mate, absolute pleasure. Thanks for having me.
We'll see you all soon.